Okay, flow meters. So obviously within any sort of off-highway, agricultural, marine, there is always an element of hydraulics involved within this machinery. Now, Pico, we do have a flow meter. It is made by Webtec, and we have 3 different types. There is a 25 litre, there is a 300 litre and a 600 litre. The 300 and the 600 both come with a loading valve on the front. Now that is there to apply load to the hydraulic system to imitate some sort of load on the hydraulic system. We have our WPS 600. There is a connector on the top. There is a pressure port. It is a standard mini-MES 1620 port which we can connect to, and there we have our pressure signal. On the top of the flow meter there is 2 outputs. There are B and C, and one is labelled T and one is labelled Q. T is for temperature and Q is for flow. So there is these are all 3 of our flow meters are turbine driven. For every turn of the turbine, every pulse that's emitted, there is like an inductive pickup within inside here, which then we can obviously put into our Pico software and then actually convert that into a litres per minute value. You'll see on the front, one of the things that we need to be very conscious of and make a note of is the K factor. In this case, it's labelled the PPL output. So there is the number of pulses per litre. So in this case, this is 132.7. Now that value we will need to import into PicoScope 7 so it can make the right conversion. Temperature. In order to get temperature out of the flow meter, we need to be using this adapter. Now these come with the flow meters. They are already in there with the kit. One thing that isn't in there is the battery. So you will need to put a coin type battery, which is a 2032 cell, 3-volt cell, and that will power the device. There is this little 3.5mm jack adapter that will take the BNC end. When you plug it in, it will turn the device on. If you leave it plugged in, the device will continue to drain, so it's kind of like the on and off switch as well. So once you're done with the temperature thermistor, just disconnect it, and obviously the battery won't discharge. So setup-wise then, if we were to say we'll have pressure on channel A, so we're going to connect that to WPS 600, and we'll connect that to channel A on the scope. We'll then have flow on channel B, so connect that to the Q output on the flow meter, and then obviously channel B into the scope. And then channel C will be our temperature. So we connect our BNC to BNC lead, and then obviously to the 3.5mm jack thermistor. Once that is all set up, obviously being all BNC, we do need to tell the software what we have connected, so we'll run through the setup in a second. When you connect the flow meter to the implement or to the, however you would like to do it, in this case we are going to look at it on the back of the remotes of a tractor. Always make sure the loading valve is turned all the way out, so completely, fully unwound and open. That will prevent any problems when you start the machine up and inadvertently have a restriction which could potentially cause something to potentially cause damage. All right. The flow meter is protected, so there is a pressure limit on the flow meter. I think for the 300 it is 400 bar. There is a burst disc in the back of these that will pop should that pressure get above 400 bar. If we look at the back of the flow meter, there is a little separate section here. There is replacement discs that are featured within this. To get to these burst discs, and hopefully you won't ever have to, take off the back of the flow meter and there is a set screw in there. You disconnect that and obviously you will be able to replace the burst disc. There is a preferred path that the flow meter has, and you can see this on the front. There is actually a slightly larger arrow. That just means that its preferred direction is to go from this side, coming in, and then coming out of the back. This is a bidirectional flow meter though, so if it was routed the round the other way, it wouldn't matter, it would still work. Okay, what we're going to do now is we're just going to cut away for a second. We're going to set up on this machine, and we're going to then actually go through the software, get it all up and running, run the machine, and actually do a pressure and flow measurement. Okay, so we've now set up on the machine and we've set up our pressure and flow meter, and I've also included an additional channel which is going back to the crankshaft sensor. The reason being is that we can start to see how hydraulic pressure and flow are affecting the load on the engine itself. So what we'll do is we'll get the machine started up and we'll start running the test, and as the machine's running we're going to start increasing the load on the hydraulic system by using the loading valve on the flow meter. We've got a new view within the PicoScope software itself. So this particular test actually has the XY view as well. What that will mean is it'll allow us to plot the relationship between flow and pressure. This is predominantly called a PQ curve within the hydraulics industry. That can be really helpful when you're trying to determine possible issues with hydraulic pumps. By including the crankshaft sensor on there as well, if we know the actual displacement of the hydraulic pump, we can now do something called efficiency testing, because we get a theorized flow rate using the speed of the pump against the flow rate. So there we've got our efficiency ratings as well. So if we could start the machine and engage the remote, and then we can start getting the flow meter reading. Okay, so the machine is up and running. We have our crank signal on channel A, we have our pressure on channel B, which currently is sitting at 14, 15 bar, and we have our flow reading as well, which is sitting at around about 70 litres a minute. Then within the XY view, if I bring out my time ruler, it's no longer in time, it's in pressure. And then against flow, we have 15 bar of pressure against 70 litres per minute. We're just going to restart the capture, and then we're going to start increasing the load on the hydraulic system. Gradually wind the flow meter in, and as the pressure starts to increase, we'll start to see that movement on the XY view. You can also hear the engine starting to labour down. Now in this situation there is a relief valve within the remote block, which means we can't, even if we restricted all the flow all the way up, we're not going to cause any problems. We're just at maximum pressure now. We can see that in the PQ curve in the XY view as well, where it's tailed off. Now again, we can start to release the load on the hydraulic system by opening the loading valve on the flow meter. Nice and slowly and gradually. You can see flow start to bring up, and we can see the pressure drop away. Unwinding the loading valve all the way up as well, just to prevent any problems in the next test. Okay. Cool. That's well. Perfect. Okay, let's stop that capture. Let's have a very quick look, and we'll just put some maths in to actually show how the engine speed changed as well. But here we can see we've got an awful lot of information about how the machine was operating when it was under load and how the pump performance was taking place as well. One thing I forgot to mention was actually the temperature. Now obviously, because we're graphing temperature, we can see how by loading the hydraulic system starts to increase the temperature of the oil. It would naturally do this anyway, however by putting extra effort on the hydraulic system does also bring the temperature up. This is quite important if you're looking at it from a maintenance point of view. If you wanted to do this test periodically, you want to make sure that your temperatures are going to be about the same for each test. Hydraulic oil behaves very differently at different temperatures, as does all oils. So let's look at channel A, and we're going to add in our mass channel. As before, we do use the crank A of 60. Now we've brought our mass channel in. Now we can see that we've actually gone outside the range of the built-in mass channel. So let's edit. We're going to keep the same mass channel. We're just going to increase our RPM. So let's put it to, say, 3,000 RPM. Click Finish. And hopefully now we can start to see how the engine speed, well, it doesn't really change an awful lot, does it? It's pretty static all the way through, which indicates that the engine is more than capable of performing and meeting the requirements from the hydraulic system when it's under load. So again, if you potentially have an engine that's dropping its RPM as you're loading the hydraulic system, where do you start? Is it the engine or is it the hydraulics? In any case, I would always start with the thing that's actually moving the hydraulic system to begin with. If you can verify that the engine's in good working order by using some of the tests that we've already shown, some non-intrusive testing using exhaust manifold pressure, using the crankshaft to actually plot how each cylinder is contributing to the crankshaft speed, checking the injectors, seeing how they're looking and how they're performing individually, and against each other with the reference waveform. There's a lot that we can do in a very short space of time to try and determine what's going on with a machine. But that's the flow meter in action, and I hope that helps.